equal ratios. Let's recall it. If first I will be writing a title, theorem on equal ratios. If A by B is equal to C by D, then what theorem of equal ratio says? Each ratio, that is A by B is equal to C by D, is equal to addition of numerator upon addition of denominator. A plus C upon B plus D. It can be generalized as well. In general, if we are having 3 to 4 ratios, say A by B is equal to C by D is equal to C upon F, say dot 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 dot. And if we are having some non-zero scalars, non-zero numbers, you can say, what is that, say L, M, and these are non-zero numbers such that the linear combination, that is L multiplied to B plus M multiplied to D plus N multiplied to F, these all are non-zero. Why they are non-zero? Because they are going to be in new denominator. So once the linear combination is non-zero, then each ratio that is A by B is equal to C by D is equal to E by F is equal to, we don't know the terms, how many terms are there, is equal to, just as we are multiplying L to B, we need to multiply same term L to A. So LA plus NC plus NE plus dot 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 divided by LB plus MD plus NF plus dot 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 dot. As this is non-zero, so that it can be in denominator, no issues. So from this, we conclude that if two ratios are equal, then it can be generalized either in the form of addition or in the form of subtraction, which is called as theorem on equal ratios. And as per requirement, as our question is demanding for the situation, we will subtract it or add it as per the demand. So let's move to the practice set that we have left last time. We were doing practice set 4.4. In that, we have completed almost 2 problems. In second problem, we need to get the value of Mn. So let's do that. The given is 5m minus n. 5m minus n is equal to 3m plus 4n. This is given part. And after giving this, they are asking us to find the value of. I have derived the first one, and I've asked you to solve the second one. So let's do second one as well. No issues. To find 3m plus 4n divided by 3m minus we need to get this value. How to get this value? So last time we have derived and got the value of m by n. So let's get the value of m by n again. From this equation, from equation 1, what we are having, just take all the terms of m together, that is 5m minus 3m is equal to 4n. Taking minus n to right hand side, we take a positive sign. So 4n plus n. So what we are having, 5m minus 3m is 2m and 4n plus n is 5n. So at ultimately we want the value of m by n. So what we will do, we will just take 2 to right hand side and n to left hand side. So m by n becomes 5 by 2. Hope you have understood this. Once we get the value of m upon n, so as per requirement, we can see that we want value of 3m plus 4n and 3m upon 3m minus 4n. So along with 3 or along with m, we are having 3 and along with n, we are having 4. So what we will do, we will multiply. So therefore, 3m upon 4n. What we are doing, we are multiplying by 3 by 4 on both sides. If you don't understand like this, we will write the reason. 3 into 5 upon 4 into 2. Just write since multiplying multiplying 3 by 4 on both sides. So 3m upon 4n. Why we are very much intended to get 3m upon 4n? Why not 4m upon 3n? Because we can see into find along with m, what was the number? 3. So my intention was to get 3m, and along with n, we were having 4. My intention was to get 4 again. So this is like common understanding. In order to get 3m upon 4n, we should multiply by 3 by 4. So our demand according to the situation was 3m and 4n. So we did accordingly. So what is the answer? 3 multiplied by 5 is 15 and 4 multiplied by 2 is 8. So we got the value of 3m upon 4n as 15 upon 8. Now, we want addition in numerator and subtraction in denominator. So what we will do, by componendo and dividendo. By componendo and dividendo. We get, what do we get? I'll write on the top now. Three m plus 4n upon 3m minus 4n. So as we are adding, according to componendo, we are adding in numerator, and according to dividendo, we are subtracting in denominator. So 15 plus 8 upon 15 minus 8. What is the value of 15 plus 8? It is 23. And 15 minus 8 is 7. So this is the answer for the given or asked expression, you can say. Asked expression. So we have completed the second problem. Now we'll move to third problem. Yeah. So next problem is that what is given? Question number 3. given a into y plus z is equal to b into z plus x is equal to c into x plus y. This is the equation that we are having, out of which a is not equal to b is not equal to c. Why? Because they have given the statement, and out of a, b, c, no two of them are equal. No two of them means neither a is equal to b, nor b is equal to c, nor c is equal to a. And show that by this we can conclude that a minus b is non-zero. How you got this? What do you do? Just take the combination. A not equal to b, take another combination. B not equal to c, take one more combination, that is a not equal to c. So from here, what we will getting? Take b to left hand side, so it will take a form of a minus b not equal to 0. So how we are doing? Just we are taking additive inverse on both sides. Like we are subtracting by b on both sides. So a minus b not equal to 0, and here b minus c not equal to 0, and here a minus c not equal to 0. So this is like a protocol or a basic idea behind mathematics, that we are using additive inverse. Hope you have understood this step. So this is a given part, and no two of the number is equal means we are having this conditions. So they are asking us, by giving this condition, they are asking us to find we need to get the value of y minus z upon a into b minus c is same as z minus x divided by b into c minus a is equal to x minus y upon c into a minus b. We need to find, in the sense we need to show this. We need to show that each ratio is equal to show. If we will show this, means we are through. So by using this condition, we need to derive y minus z. So what we need to do first, as we can see that we require a, b, c in denominator, a, b, c, and there by observation in a given part we cannot see a, b, c. So give it equation number 1. Dividing equation 1 by a, b, c. Throughout we get a y plus z divided by a, b, c. B z plus x divided by a, b, c. C x plus y divided by a, b, c. So what we can see is present in numerator as well as in denominator. A. Strike this A. Here, what is same in numerator and denominator? B. Cancel this B. Here, C. Cancel this C. So what remains right there? Therefore, y plus z divided by bc Z plus X divided by AC, X plus Y divided by AB. So after this, now we got ABC in denominator. Means here we can say BC, here we can see AC is present, here we can see AB is present. So now we just want to see that what is our requirement. First, this is our ratio. As earlier we used to have A by B equal to C by D. Now we are having Y plus Z upon BC is equal to Z plus X upon AC. So instead of A by B and C by D, we are having Y plus Z upon BC. So this is our ratio. And whatever we are going to solve, that will be equal to this each ratio. So which we will get by using theorem on equal ratios. So let's start with the step. Sorry. What we will do? First, we want to get y minus z. Y minus z means we need to use theorem on equal ratios. Yeah, exactly by theorem on equal ratios. But in order to get the rate of x, so choose those two ratios in which x is present. So here we can see that x is not present, y plus z is there. So don't select this. Select z plus x and x plus y. As we are going to subtract, x will cancel each other and what will remain? Y and z. Okay. And as well, we can see that y minus z is there. So we will be using this term first. Right. By theorem on equal ratios, each ratio equal to by theorem on equal ratios. Each ratio is equal to, as we have decided, we need to take x plus y first. And I have discussed why we are going to take x plus y first. Minus z plus x divided by AB minus AC. Hope this step is okay. My theorem on equal ratio says just whatever the ratio you are having, if you're going to add them or subtract them, they remains the same. We are doing the same as per requirement. Our demand is for subtraction, so we have use subtraction instead of addition. Just open the bracket, x plus y minus z minus x upon, just taking a common, b minus c. Cancel this x. The terms with opposite sign gets cancelled, and what remains is y minus z upon a into b minus c. So this is our first ratio, so you can write it equation 1. Or we have already used equation 1, so this is equation 2. Now that is second is of the type z minus x. So we will subtract those two terms in which y is common. So first and last. And what is positive? Z is positive. So y plus z will be first. Okay. So by theorem on equal ratios, each ratio by theorem on equal ratios, each ratio is equal to what we want? The demand is of z minus x. So as we have decided, it will be y plus z minus last, that is x plus y divided by bc minus ab. So just open the bracket. Y plus z minus x minus y divided by b c minus a. I've taken b common, and what we can see is we can subtract y, or we can cancel out y, as they are present with opposite signs, so y gets cancelled. So what remains is z minus x b into c minus a. Okay, let's move to third part. Assuming that you can easily solve it, but we'll do it. Full problem, no issues. This can be easily solved again. So as per requirement, we can see that our demand is of x minus y. So if you have written, just see there. A theorem on equal ratios. Each ratio. Yes, now you should say what we are going to select. The requirement is of x minus y. So select those two terms in which we are having z common, the first and second term. And x is positive, means second first, and then second one. So z plus x minus y plus z what is the value of plus z plus x is CA minus y plus z is BC. Let's open the bracket. Z plus x minus y minus z divided by, you can see that C is common, take it outside, A minus B remains. And cancel the term with opposite sign. Z gets cancelled. What remains is x minus y divided by C into A minus B. Well, this is our answer. So we have completed third problem. It was the proper application of the harmonical ratios, in which after having our ratios in different form, asking something to show the required scenarios. So what we have done, we have found equation 2, equation 3, and equation 4. So from equation 2, 3, and 4, what we can conclude? And conclude the required, whatever they are asking us to show that. So from equation 2, 3, and 4. the whole ratio, whatever they were asking us, we can say that each ratio is equal means they are equal. So y minus z a into b minus c is same as z minus x upon b into c minus a is same as x minus y upon c into a minus b. That this was the required solution for the given third problem. So let's move to fourth. Even that is same as that. Only the difference is that in this case they have given us something in denominator, and they're asking us to show that each ratio is equal to one. So let's do it. So question number two, third two. What they have given x upon this given part x upon 3x minus 3x minus y minus z is equal to y upon 3y minus x is same as z upon 3zx minus 3z minus x minus y with a condition x plus y plus z not equal to 0. Sorry, x plus y plus z not equal to 0. We need to show that each ratio to show that each ratio is equal to 1. This sort of means we need to solve this and just need to show that this is nothing but equal to 1. So by theorem on equal ratios, we will write here each ratio is equal to, just need to add this x plus y plus z upon. Why we are doing this? Because they have given us directly that x plus y plus z is not equal to 0. So what we will do, we will add all the denominators and numerators. We will apply directly 3x minus y minus z plus 3y minus z minus x plus 3z minus x minus y. So what we need to get here is x plus y plus z divided by 3x. We are having minus x which is minus 2x plus 3y. We are having minus y, we are having minus y, so minus 2y, 3z, so we are having minus z and minus z, which is minus 2z. Just subtract the terms. That is reminding us to subtract. So we are having x plus y plus z divided by 3x minus 2x is x 3y minus 2y is y, and 3z minus 3z is z. Now, as x plus y plus z is present in denominator, we need to justify, or we need to say that the term present in denominator is non-zero. Why? Because we are going to cancel this. Once you are cancelling any term present in denominator, you should say that it is non-zero because you cannot cancel 0. And the term present in 0 tends our whole term to infinity. So that should not be 0. This is the condition why we should. So because of that only they have given us x plus y plus z not equal to 0. So each ratio is equal to 1. So we have proved this. So remaining problem of question number 3, that is the third, fourth, and fifth is being omitted as per reduced syllabus of state board. So just strike with pencil third, fourth, and fifth. Now we will move to question number 4. In question number 4, there are two problems. Actually, both are simple, but it's okay. We have done this in 4.3, this type of a problem. So this time we will solve it, but by using theorem on equal ratios. So only the difference is that means they just want to say that we have solved this type of problem by using component and dividend, but this time again solve the problem by using the condition of by theorem on equal ratios. So I'm solving question number 4 first for you. First one, 16x square minus 20x plus 9 divided by 8x square plus 12x plus 21 4x minus 5 divided by 2x plus 3 . So this is given and they are asking us to solve this. Solve this in the sense just get the value of x. So just go through it and try to correlate the coefficients and the term present. We can see that here we are having 16 and 20. Here we are having 4 and 5. What we should multiply with the term so that that we will get the same terms present here. So what should be multiplied with 4x? If we will multiply 4x with 4x, so what we will be getting 16x square. Yes or no? Very simple. And what should be multiplied to 5? So that we will get 20. 4 should be multiplied. We will to 5 we will get 20. So this is our observation. We need to correlate and need to get the common multiple or the term multiplied with the terms in order to get the same expressions present so that we can apply our theorem on equal ratios. So we cannot apply theorem on ratios directly. It requires understanding and the terms should be proper so that after correlating we can discard some terms and get the required answer. So as well we can see here if we will multiply 4x in denominator as well, we will be getting go to the 8. And we should be multiplying 4x to 3, so we'll be getting 12x. So let's see. By multiplying we'll start with a solution. Say this is my equation 1. Multiplying equation 1 by 4x only in second ratio. This is our first ratio and this is our second ratio. So in order to convert it to 16 and 8, we need to multiply the second ratio by 4x. By 4x only, second ratio. We get 16x square minus 20x plus 9 divided by 8x square plus 12x plus 21 is equal to, as we are multiplying second ratio by 4x, just write the second ratio in bracket and outside we need to, means it's not changing the meaning as we are multiplying and dividing. No? Plus 4x by 4x in numerator, we'll be writing only multiplying, so only we can multiply, not we can divide. So in numerator and denominator we should write. And denominator. Of second ratio only, like this. Multiply equation 1 by 4x in numerator and denominator of second ratio only, we get. So 16x square minus 20x plus 9 divided by 8x square plus 12x plus 21 is equal to, and 4 4s are 16, 16 x into x is x square, 4 5s are 20, and along with that we are having x divided by 4 2s are 8, x into x is x square plus 4 3s are 12, 12x. Okay. So now we can see that we got the ratio in which we are having some common term. So what we can do is we can just apply by theorem on equal ratios. Each ratio is equal to. And we need to subtract now. So when we will subtract, we will be getting the terms, constant terms, and we can correlate that constant term to any of the ratio that we want. We will be correlating with 4x minus 5 because it can be easily solved. Therefore, by theorem on equal ratios, each ratio is equal to plus 9 minus 8x square plus 12x plus 21 minus 8x square plus 12x. This is by theorem on equal ratios. Just open the bracket. We will be cancelling the terms. 16x square minus 20x plus 9 minus 19x square plus 28 divided by 8x square plus 12x plus 21 minus 8x square minus 12x. 16x square gets cancelled. 20x gets cancelled. Terms with opposite sign. 8x square minus 8x square gets cancelled. Plus 12x minus 12x gets cancelled. What remains? 9 upon 21. 3 3s are 3 7s are. Sorry. So we can use this value of each ratio to any of the one ratios. So I'll be using it to the second ratio, that is 4x minus 5 upon 2x plus 3 is equal to 3 by 7. So therefore, we can conclude that 4x minus 5 divided by 2x plus 3 is equal to 3 by 7. Just cross multiply this. As we want to get the value of x, what we will do? 7 into 4x minus 5, 3 into 2x plus 3. Seven fours are 28x. 7 fives are 35 is equal to 3 twos are 6x plus 9. So this step is okay to you. What we need to do is to take together terms with variable and a constant term together. So 28x, taking the 6x to the left hand side, so it will take a form of minus 9, taking 35 to the right hand side, so it is plus 35. 28x minus 6x, answer is 22x is equal to 35 plus 9 is 44. So just divide this, x is equal to 44 upon 22. 22 ones are, 22 twos are. So we got the value of x as x is equal to 2. So you can try the one problem which is remaining by yourself. Very easy. Just apply theorem on equal ratios, get the value of constant which is equal to each ratio, and equate it to the second ratio in the given expression and get the value of y. So enough for today. In next lecture, we'll start with continued proportion. Thank you, everyone. Ma'am.